Assalamu alaikum. Now let's get to a question which says, what is the difference between electrical force and gravity force? We said before, Coulomb, he proved his law by taking an example from Newton's general law of gravity. Now if we compare between those two forces, electrical force and gravity force, first one says it is the attraction force or repulsion force. It could be two types for electrical charge, but here it's always attraction force for gravity. Second one, charge could be negative or positive. Here mass is always positive. We have most important part mass here, the most important part is charge here. Third one, force is large, but here force is small. According, if you compare between those two, the electrical force is larger than gravity. And this is the law, Coulomb's law for electrical force, and this is Newton's law for gravity for one object. Fg is equal to m times g. Coulomb, while proving his rule, he used a device called as Coulomb's torsion balance device. He used this device to prove the inverse square law that he used in his rule. In here, if you can see, this rule we said it's called as inverse square law, and he proved this rule by a device which he invented. It's called as Coulomb's torsion balance device, which is composed of a charged sphere and charged object inside a glass tube. The question says, Coulomb's torsion balance is used for what? It's used to prove inverse square law for two charges have distance between them. Now let's get to sample problem 6a. Sample problem 6a in your book at page 181. If you check the question says the electron and proton of a hydrogen atom are separated on average by a distance about 5.3 times 10 to the power minus 11 meters. Find the magnitudes of electric force and gravitational force that each particle exerts on the other. So we have two parts here in this question. First part, it says find Fe, the electrical force between charges. Second one says find Fg, the gravity force between two charges. What's given here? You have some constant. We said you have to know from the table. R is given 5.3 times 10 to the power minus 11 meters. This is the distance. Mass of electron is given 9.109 times 10 to the power minus 31 kilogram. We took from the table. Mass of proton is given 1.673 times 10 to the power minus 27. QE, charge of electron. QP, charge of proton, which is both 1.6 times 10 to the power minus 19. And Kc and G, they are both constants. The Coulomb's constant and gravity constant, and we will use it in the rule. Now let's get to the first part. The first part, we want to find Fe. Fe is electrical force, which is equal to Kc times Q1 times Q2 over R square. Now both Q's have the same value, so we can do it like that, 1.6 times 10 to the power minus 19 square. It doesn't make difference because they have multiplication between them. You can write them differently and then multiply, or you can square them. You will get the same result. The charge of electron is not very important. here, negative or positive. It's just a sign to understand that electron is negative. And we will replace the numbers. Instead of Kc, 8.99 times 10 to the power 9, and Q1, Q2, we squared them because they both have the same value, 1.6 times 10 to the power minus 19 square, or you can multiply them differently, and over 5.3 times 10 to the power minus 11 square. But be careful about those squares. Those squares are important. Sometimes students forget to square those values. So how do you calculate this? You can multiply this 8.99 with 1.6 square this, and then multiply it by 8.99, and then divide it by 5.3, or you can directly divide square 1.6 and divide it by 5.3, then multiply it by outside of the parenthesis. You will get Fe 8.2 times 10 to the power minus 8 Newton.